about the length of some of these axons. They're very long. For example, ever hurt your toe? Okay, you know, like, I don't know, oh, my last pedicure. Pretty sure the girl tried to cut the toe off. Okay, I'm heading into the 4th week. It's still injured. Yes. Okay? Still hurt. So if I've taken a leave or something, or whatever, do you really get any relief? No. The only way to really get relief is for somebody to like inject pain medication directly into that area. Why? Because it is so far away. In the terms of where I might have the nerve cell body and then the axon with the terminal end meeting the area, in our terms of our body, thousands of miles. That's a long way for that little bit of the lead to travel. And so it just eventually goes, I'm not traveling anymore. So you don't really get any relief for the toe. Go figure, right? In the white matter, we're going to see the axons. They are going to be able to have that ability for information to come in and responses to go out. What we're going to find, we're going to have the ability for information to travel up the spinal cord and responses to travel down the spinal cord. So the white matter is going to contain these columns with tracts, T-R-A-C-T. Now, if you were in this course to become a neurobiologist, I would want you to be able to know every single one of these tracts. I'm going to try to make that easier for you. Okay? One of the things I want you to know, we have what's going to be termed ascending tract, meaning information moves up. And I'm going to have descending tract, information moves down. Within them, okay, they're going to have really cool names. All right, somebody got really inventive in lab on these days. Okay, we're going to see that these columns or funiculi. Anybody know what that might mean in another language? Okay, I don't either. Just was asking, just to see if anybody. Because somebody did tell me what lacuna meant one time. Y'all remember that from part 1? Okay. I did not know that that meant little home. Okay. So I'm like, oh, so it's the little home for the bone cell. Just saying. Now, we're going to find the columns, or known as the funiculi. There's a posterior, being, anterior, front, lateral, side. We just learned that we've got posterior, anterior, and lateral, right? So wouldn't it stand to reason I've got columns for each of that information? Yeah. See how that hangs together right there? Okay, so tracts are going to be those subdivisions. Read those for a second. Or if your eyes are good enough and you can read them on your, I can't read that. I can't, oh, you can't, okay, so your eyes are not, okay. So, see why I'm not going to ask you to know every single one. What I want you to know, these give us information in some way. One of the things that we'll know, first of all, is information going to be going up or is information going to be going down? Then the names of those tracks corticospinal. Anybody know what that means? Right? If you take the term apart, what it's telling you is where the information starts and where the information ends. So if I've got to have information going up the spine, down the spine, those tracks are telling me where did the information start, where did it end. For example, corticospinal is letting me know cortex of the brain, and then in the spine itself is where the information is going up and down. Does that make sense? So even though your textbook is going to get into much great detail about every single one, I want you to, number one, to be able to understand what is meant by the ascending tract, what is meant by the descending tract. Understand that I have them posterior, anterior, lateral. Now associate where information for those areas are, okay? Like the lateral horn, that was associated with what part of my body? My organ. So therefore, those tracks on the lateral side, what should they be associated with? My organ. Does that make sense? So it's not that I want you to be able to be specific about every single one of those tracks. I don't. I understand ascending, descending, posterior, ventral, lateral, information in, information out. If information is coming in, which way do you think it needs to go? Ascending or descending? Ascending. If information comes out, it needs to be descending. So sensory in, motor out. Okay? So, which part?
The ascending tract and the descending tract and sensory coming in and out.
If we're going to have sensory information come in, it needs to ascend. So it needs to go ascending tract. Motor information needs to go out, and that will be descending tract. Okay? So, it's not that I want you to get into great detail. It's kind of, once you begin to put that information together, you kind of see, oh, okay, well, I know that I got to have information come in. And if information comes in, the area that registers, that kind of like recognizes that information came in, is my brain. My brain is up here. So that information that comes in needs to ascend. Well, okay, I got the information. I need to integrate it. I need to get a response. Well, some. Notice I said some. not all. Okay? Most of the information has the response, yes, coming from the brain. Okay? So that means this information needs to go down. And when information, I get the response, it causes an action. Therefore, motor. Those would be my motor causes.
Now, how does this all work when we're dealing with reflex, with things that don't go all the way to the
Hold
brain?
on to that thought. Because we're going to learn that with the reflex, it happens right there at the level of the spinal cord. And we're going to talk about the different kinds. We're going to talk about those reflexes.
So gray matter would be
Now, you're going to find that tracts are going to be, you're going to find that there are going to be the tracts in the different areas of that spinal cord in those directions. I think in one of the pictures, okay, this right here is kind of showing information, the areas, the tracks, that information goes up, and then this right here representing information going down. If we're looking here in this gray matter, what did we say was found? What part of that nerve cell was found in the gray matter? Cell body. Cell body is integrating the information. Does that make sense, Anthony? So if I look at my track, they're trying to show me that, okay, on this, what looks like the left side, being represented by the red, are my ascending tracts. Where's my ascending tracts on the right side? They're there. They're just not showing them in red. Does that make sense? Okay. Then, on the right side, they're trying to show me my descending tracts. They don't have anything marked in green on the left side.
So these are mirrored. They just don't show up on the picture.
They're just not showing red all at the same. Does that make sense, Anthony?
Like looking up in the strip.
In other words, I could take a red pen and mark the same colors on the same side. Yes. But see, there's a reason that it's being represented this way. When things happen in the body, all right, when information goes up and responses come down, a lot of what you're going to see happen is if it enters on the right side, it will cross to the left and go up. If it enters on the left, it'll cross on the right and go up. For the most part. You know how people are like, oh, well, if it's your, like, stroke or something like that, and maybe they've got some paralyzing on the right side, they'll say, well, the damage is done to what side of the brain? The left. Okay? For the most part, yeah. Okay? Where this is going to become interesting is when we have to have a reflex. Now, wait a minute. Reflex.